Salutations Ape-Friends, my name is Owen Kirby and today I'm going to show you how to build a really cool audio delay effect in TouchDesigner. Okay, so first off I'm going to show you this component I built called DubDelay, which is a comprehensive audio delay effect for TouchDesigner. It's got pretty much all the features that I would want in a delay, and if you want more features, well, it's got this handy effect loop that allows you to tweak the tone and add, make some crazy experimentations with it. So I'm going to take you through the features real quick, and then after that we're going to dive into how you can build your own delay or incorporate some of the techniques here into whatever other sort of wacky effects you want to do. Alright, so here it is, DubDelay, being fed by my simple synth. So you've got a BPM parameter, you can sync the delay to the BPM, got mono or stereo operation, got feedback, delay time, delay BPM sync. Oh, what's that I hear? Woo! Variable pitch. Now I should start by saying that this might seem obvious that it's possible to achieve this effect, but I've spent a lot of time trying to figure out how to get proper delays in TouchDesigner. A lot of the times, because of the time slicing, you may be able to see it here. You'll get some cuts in the audio, and it's hard to get consistent results, but I think I've found pretty much the way to achieve it. And so as we're going through this tutorial, there's probably going to be a couple of times in which I'm going to have to go back and then fix some issues until we finally get the desired result. So let's keep going here. So we got this delay, variable speed. We can have it in stereo. Oh yeah. Positive, negative feedback. You have selections for feedback times. So the great thing with finally having variable speed delays is now you can achieve certain effects such as flanging, right? Using this modulation section over here, which can also be synced to BPM. So this might be a classic, well, it's a stereo flanger, so it's not quite classic. It's actually pretty nice. And you've got an envelope follower, which allows you to modulate the flange itself. Positive, negative feedback changes the quality of the flanging. Instead of adding to the feedback source, it subtracts from the feedback source, and when using it in a flanger, you get the difference between a more tubular effect or a more resonant metallic effect. And so you've also got an envelope follower in there, which allows you to modulate the modulator itself. And last, which I think is really the cool feature here, you got this effect loop. So a lot of traditional sort of dub delay effects, which I'm a huge fan of, or analog delay effects, feature this sort of darkening sound as the delay trails tend to trail off. So here, audio parameter EQ. Here, using the effect loop, it's possible to add an EQ within the feedback loop, and I think you'll notice the difference in the quality of the delay reverbs. So the first thing you may notice as well is that sometimes the delay crackles, and that's totally normal. There's a bunch of reasons going into why that might be, but usually it works in perform mode for reasons we'll get into later, but it does take some pretty specific setting up. So anyways, that's the dub delay. You can get these sort of cool tape delay effects, which I quite like. Okay, enough of that. So let's get to it. So the first thing, like with any component, that I like to do is sort of know where I'm going first and then go straight to it. So we start by dropping a base so that you'll have this effect compartmentalized, and then you can copy paste and reuse it in other projects. So this base, delay, the name's already taken, so we're going to call this delay number 1. Okay, so it's a delay. What are the parameters to a delay? Well, there's the delay time. Page name. Delay, add page. Delay time is going to be our first parameter, and it's going to be a float. And then our next parameter is going to be the feedback circuit and how much of the delayed signal gets fed back, giving you those nice sort of echoey trims. So delay, feedback. So you may notice it's quite a bit less parameters than in the DubDelay component, which I'm selling on Etsy. And if you want to support these tutorials or my work and stuff, you can buy it on Etsy. There's a couple of cool techniques in there as well you can dig into once you have the component. And it'll save you a lot of time, like putting in, they're essentially all the essential features, and it makes it really easy to drag and drop and then go from there as you're like ready to use the delay effect. So it's 25 bucks, it's on the Etsy store, and yeah, it'll save you a lot of time. Okay, so the first thing in the base is we're gonna have an input and an output. I like to color them red for audio, just because that's the way I like to work. So you may know that there's this chop called the delay chop here in the standard sort of channel operators. We're not going to use it because it's kind of limiting, and I haven't gone, after just a bunch of experimentation, there's a couple of things. Like, I've experimented a lot with trying to find the best delay technique, some of which involves like even outputting the sound onto the GPU and then delaying the pixel information, stuff like that. That was more reliable in terms of time slicing, sort of distorting the sound. But this is the best technique that I've found. So the way delay works is all the audio information gets stored in a buffer of a certain length, and then it gets recalled from the buffer. So you can think of this in sort of traditional analog terms. If you have a tape being played, it's like a tape head that's played back further beyond. So that's what we're gonna go for here. We're gonna go for this sort of tape analogy. And so we're gonna use a trail chop. And that's gonna be our first thing. That's gonna be our buffer. We're gonna get the signal in here. And bam. Here it is. And you may notice a bit of crackling. We'll get to that later. Actually, I'm just going to pause that for the time being. Okay, so here is our delay buffer, the length of which is 4 seconds. So you can change the length, for optimization purposes. That's one of the features in the DubDelay as well. It's like, depending if you want to just use it for flanging, then bam, like cut down on the buffer because you won't need to store that much information into it. So here it is. Here's all the information we want to get. It's delayed by 4 seconds. So it's there. And now the question is going to be like, well, how do I retrieve it from there? And well, we're going to use my favorite chop, which is this one, the lookup chop. It is absolutely my favorite chop. It is super helpful in a bunch of ways. So lookup chop, if you don't know, the first input are the index numbers, and then it looks up here at that index, right, which are the sample positions of the channels. What's the value? Okay, so we know that, but we also got to know, like, what is audio in touch exactly when we're looking at an audio channel. So we can just look at this null coming in here, and we can see that there are 735, that 735i, that's the number of samples at a sample rate of 44.1. Okay, so we got to get something that looks like that in here. So normally, what I like to do is to use a pattern chop, not quite like that, but it's a ramp, right? We're going to go from 0 to 735. So the length is going to be 735 samples. This is going to be kind of complicated if you're a bit of a beginner in TouchDesigner, but you can just follow along and at least you'll be able to reproduce the network. I'm wondering how in depth I'm going to be going into sort of the theory behind this. But here we're going to start. Okay, so we got our first issue. It's just bumping up and down. Why would that be? Sample rate mismatch. That's something to be troubleshooting when you're working on audio networks. Make sure your sample rates are matching. So here we go. Still not working. What have I done wrong? Aha. Here, the index range. It's going from 0 to 1, and we've got sample channels going from 0 to 735, so it's way out of range. So what should the range be? So the range should be the length of our sample buffer. And the way we can check that out is, okay, now it's 4 seconds here. So let's look how many samples that is. Okay, so we're just gonna copy that into there. Bam bam. Okay, something else about audio channels. Actually, we're going to start plugging this into the audio, and then you'll be able to see, you'll be able to hear the troubleshooting process as it goes. Ooh. Doesn't sound right, does it? So let's look at this next thing over here. You can see that the sample indexes are remaining the same from 1 to 2. Whereas here, you got a count up that's synchronized to the timeline. So this is part of the time slicing properties of audio in TouchDesigner. It's what, it's a really handy feature. It's what sort of keeps all the animation smooths when you drop frames and sort of like buffers all the information and interpolates when you're dropping frames. And that's really helpful. But in audio, it results in a lot of crackles and pops and a lot of troubleshooting because you might have changing sample lengths depending on whether it's trying to catch up to lost frames or not. So it's kind of a tough thing. Here we don't have time slice, so we're going to use the time slice chop over here. And we'll see there's already a difference here, it's counting up. But it's still, okay, yeah, it's still not giving us what we want. Whereas the audio parameter EQ will give us what we want here, and we can even disable the EQ. Oh, that's starting to look more like audio already. Okay, so that's one way to do it. Now let's hear if our sound's being delayed. So we're going to use a crossfader here, so we get an equal mix of both the dry value and the wet value. Here. We can even just see them here. Okay. So that's working. Maybe we want to change the delay time, however. So we're going to call up our parameter using a parameter chop. And I like to make these black just so that I know that they're parameters. That's the way I like to work. I just like it that way. It keeps things neat and orderly for myself. Okay, so the delay time, we're going to want to be working with milliseconds in here. And what we're going to be doing is essentially moving, if you can picture this pattern of 0 to 735 as the tape head, right? And this is our buffer, this is our tape. We're going to be moving it around. So if I start reading stuff going backwards from the top, from the maximum sample length here, going down 735, that's going to be a total of 4 seconds of delay. And the further away I move it, if I move from 0 to 735, that's 4 seconds delay because the sound appears over here, moves around over 4 seconds, get there. I'm pointing at the screen, you can't see it, that's fine. So 0 to 735, 4 seconds delay, it's maximum delay range. And as I move it upwards, the delay range is going to shorten. So we're going to want to add to the base value using this parameter here, offset. But right, we're working on a range of, say, 0 to 4. Set to 0 to 1, but we can do that in the custom parameters, 0 to 4. And when you set that, so using a math, the say the maximum range, 0 to 4. And what's the equivalent in sampling time? So we saw that the samples were 176,400. Okay. Okay. Let's see if this works. Okay, that's it. So now we got this other parameter, delay feedback. So we're going to set up a feedback loop using the feedback chop. And the reason you got to use the feedback chop is because otherwise it just messes up. It doesn't know what's going on. It's in a loop. Feedback chop sort of halts things for a little bit, stores those values just for like a tiny bit, and makes things comprehensible for your TouchDesigner network. So we're starting with feedback chop at previous channels at current time, being fed into the audio power EQ that's only on time slicing tunes. Now here's the funny thing. Feedback chop itself has that time slicing behavior. So presumably we can delete this. And here we go. Okay, that's cool. So the feedback loop is going to loop back around and add its value into the trail buffer. So we're going to want a math chop, set the combined chops as add, and then we could plug it in directly, but if you're familiar with feedback loops, they tend to get out of hand quite quickly. So we're going to want to build an attenuator here in the form of another math chop. Okay, and the math chop, well, there we go. I'm going to set it to 0.3 for the time being. I already hear it. That's cool. And now let's add our parameter to that. So normally when working with audio, I like to multiply or add things by using the input connectors of the math operators. But that's mostly when I'm adding audio signals or control signals. It makes things a bit funky when you're trying to match different sample rates. So for this case, I'm going and I'm exporting it directly to the multiply. But if you'd be working with audio signals, that means that this is essentially stuck to 60 frames per second, this modulation. If you're working with other higher resolution modulation, you'll want to be doing it by those inputs. All right, so let's give that a try. Let's see how we're doing here. There we go, that's a delay. Now what happens if we modulate the time? It's kind of crackly, huh? And I don't seem to be getting that pitch change either, which is a desirable effect, like I said, for building those time-based modulation effects such as chorusing and flanging. So here's when the real trick comes up that I came across last week. It just works. I've got sort of a vague intuition of why it works. It's I'll get to it first and I'll tell you sort of how it explains it, but I haven't quite in-depth understood why it works. But it does, and that's cool. Okay, so essentially this is our tape head. This is what's being moved around. But we're going to want to sort of create the tape head in a way that samples longer spans of time and shorter spans of time, which sort of results in that pitch change effect. So I'm just going to go and show you how I achieve that, and then think of specifically why it works as I go along. So now that we've got our delay time values set in the sort of sample domain, we're going to delay one of the channels by one sample. We're also going to subtract 735 from that one. we are going to join both samples. That's starting to look like something. That's starting to look like our tape head over here. But because we've got this delay chop, it's going to be a bit stretchy. Again, okay, let's just go right into the error so we can learn from our mistakes. So maybe some of you guys already know what the mistake might be, but let's just plug it in and see what happens. Okay, sample rate mismatch. Exactly. So we're going to use a resample chop. I'm going to make sure this is how we want it. So we're going for a new rate and a new interval of an absolute length of 735 samples. Ooh, that sounds a lot better. Okay, and now for the last step, which is like, again, this was, you gotta kind of know this for it to work. So it sounds great now, seems to work. But later on, if you're building a network, you might be wondering, why are there always these dropouts in my reverb tails when it works all the time when the network is open? At least that's something that I had issues with. And the reason is that TouchDesigner works in a pull-based system. So it starts with what's on the screen and works its way back. So if there's nothing on the screen, it doesn't seem to care that much, and if things get time sliced, it's sort of less important. At least that's the way I've sort of vaguely understood it. So, so to make sure that you've always got some cooking on the screen, what I did was just set up a simple lookup system here, which I've mapped to a single pixel over here. And then this one gets output into the top level. And you can composite that into your final output, whichever way you choose. But that's it. And you can see that we can modulate as well, the delay time. Okay, so we got through it. We built a delay, it works. It's kind of wacky with the LFO. And so you can take this idea, run with it, improve on it. Or you can also save yourself a bunch of time. I'll put the link down on the in the YouTube description. Buy the DubDelay, it's really dope. Like it is. This feedback effect is really cool. If you put the whatever effects you want in the delay chain, it can be audio filters, it can be bit reduction, it can be other delays, and yeah, the stereo operation is really handy. Positive, negative feedback for flanging. You can get some really wide chorusing effects. You can get ping pong delays, which is that cool Plastic Man sound. And again, this sort of like, you know, it's got really cool features, but nothing that really adds to the cook time. It's just a question of taking the time to make the right exports, to set the ranges properly, and it's pretty time consuming. So it's 25 bucks, save yourself the time, support me if you want. Otherwise, have a nice day, make some delays, and just like have a really good time. Peace.